All right, let's get straight into it. This is a technical breakdown of the UML package diagram. We're going to focus only on the syntax, the components, and the relationships. Basically, the core mechanics of how you build and read these things. Okay, so first up, we have to start with the most fundamental piece of the puzzle, the package element itself. Everything else we're going to talk about builds right on top of this. So what does a package look like? Well, you'll see it drawn as this little tabbed folder icon. Its whole job is to be a container. You use it to group together things that are related, like classes or use cases or even other packages. It's all about creating a logical boundary inside your model. Now, here's where it gets interesting. The elements you put inside a package have something called visibility. This is just a way to control what can be seen and used from outside that package. And we manage this through two main ideas, public and private. It all comes down to the notation, and it's pretty simple. If you see a plus sign, plus, in front of an element, that means it's public. Anyone outside the package can see it and use it. You'll sometimes hear these called exported elements. On the flip side, a minus sign means it's private. That element is totally encapsulated, hidden away, and not visible to the outside world. So packages aren't just standalone boxes. You can actually organize them into hierarchies by nesting them. And this has some really important effects on their namespaces. You can literally put packages inside of other packages. And the rule for visibility here is really straightforward. If an element is public in a parent package, it's automatically visible to all the child packages nested inside it. So that visibility just flows right down the hierarchy. And this brings us to the whole concept of a namespace. Every single package defines its own little world, its own encapsulated namespace. All that means is that inside one specific package, every element has to have a unique name. Simple as that. You can't have, say, two classes called user in the same package. All right, so we get what packages are and how to structure them. Now, let's look at how they actually interact with each other. And we define that using dependency relationships. The use stereotype is your most general all-purpose dependency. It just means that something in the client package, that's the one at the start of the arrow, needs something from the supplier package, which is the one the arrow points to. And notice, this dependency is transitive. We'll unpack exactly what that means in a minute. Next up, we've got import. This one is much more specific. When you see this, it means all the public elements from the supplier package are basically copied into the client package's namespace, and they stay public. So they become directly usable inside the client. This one is also transitive. Here's a perfect example. That bigger membership package is our client. It's establishing an import dependency on the member details package. Because of that, the member element from inside member details becomes publicly available right inside the membership package's namespace. The third stereotype is access. It's a lot like import, but there is one absolutely critical difference. The public elements from the supplier are added to the client's namespace as private elements. They're only for internal use inside that client package. And just as important, access is not transitive. So in this example, the outer membership package gets access to the member details package. This lets membership use member details for its own internal business. But since the access is private, it can't be re-exported or passed along to any other packages that might depend on membership. So I've used that word transitivity a couple of times now. What exactly does it mean in this context? The idea is actually pretty simple. Just look at this diagram. Let's say package A has a transitive dependency on B, and package B has a transitive dependency on C. Well, that creates an implicit dependency all the way from A to C. A change in C could end up affecting A. Now, if one of those links was non-transitive, like access, that chain would be broken right there. Okay, this table really sums it all up. Look at the key differences. Use is just a generic dependency. Import pulls public members in and keeps them public. Access pulls public members in but makes them private. And that last column is critical. Import and use are transitive, but access is not. Understanding this is absolutely essential if you want to design a clean, maintainable system. All right, let's tackle our last topic, package generalization. Now, if you've done any object-oriented programming, the easiest way to think about this is just inheritance, but we're applying it to whole packages. So how do you draw it? It's a solid line with a big, hollow arrowhead. The most important thing to remember here is the direction. The arrow always points from the child package to the parent package. So in this diagram, hotels and car hire are the specialized children, and product is the general parent. And the rules for how this works are pretty direct. First, the child packages inherit all the public stuff from their parent. Second, a child can actually override elements from the parent. You can see that happening here with the item element. And third, the child packages can add their own new specialized elements, like the hotel in the hotels package and car in the car hire package. This is what lets you build really powerful and reusable structures in your architecture.